And I would like to invite our vendor partners. Without their help, this would not have been accomplished because they were with us, supporting us steadfastly through this thing. So first, I would like to invite of the vendor partners, Steve Alexander, who's leads of vision and technology for Ciena, has won several industry honors, including the IEEE Communications Industrial Innovation Award. It's my pleasure to welcome Steve to say a few words. Steve, thank you.
So Inder and the team, I think I just got to start by saying congratulations. That is fantastic. I can tell you there's a lot of folks that would see that connectivity on demand capability and want it immediately, right? That has been the dream of many, many organizations for years. But I do want to just take a moment and say why I think it's so important that these kinds of collaborations exist between industry and the research side. When you're in the commercial world, that's what we are. We build, commercial kit. It goes out into all the large networks all across the world. Ciena was first to do WDM. We're the first to do coherent detection. Those are the kind of typical technologies that are out there now. But those are all largely what you might call scale out opportunities. It's how do I get video to everybody's home? How do I get fiber out into the neighborhoods? How do I connect up cities and towns and build metro networks and stuff? Obviously very important, right? This is how the world communicates. It's the circulatory system of the internet. But then you meet folks like Inder and yourself, right? And you see numbers out there that start with exabytes. Now I had to go look that up when he first brought that to me. I'm going, exabyte, okay, I know that exists, but I got to exactly what exponential is that, And so what the research world brings to us is the ability to scale up in ways that we just wouldn't otherwise get that opportunity. And so it's critically important that these kinds of collaborations exist. I can tell you it has been a personal delight to see what's been accomplished here. I mean, you got to take me back to, a 15-year-old kid who figured out with a helium neon laser, he could send Morse code across the street, okay? And see what we've been able to do here with these technologies. It's personally hugely rewarding. I look at the team here that you put together, and again, congratulations. And again, in the spirit of scaling up, all I can say is, okay, all right, my friend, what's next? Come on.
I would like to invite Robert Maher, who's the CTO of Optical Modules and Coherent Solutions. Infinera worked very closely with us in the installation of the optical line system. So please welcome Rob Maher.
Thank you. So ESnet's strong vision for leadership in networking innovation and software automation that we just see draws many parallels with Infinera's vision and Infinera's mission, which is to revolutionize telecommunications networks. And we do this through innovative coherent technologies, systems for network infrastructure, and automation software for the control and optimization of the networks of the future. Our differentiation stems from our leadership in the design and US-based manufacturing of these vertically integrated solutions, which are built upon our photonic integrated circuits, digital signal processing ASICs, analog electronics, and an app-centric software suite for automation and reduced operational complexity. Again, something that draws many parallels with what Inder just demonstrated. This technology stack ensures that we can maximize capacity across any of these fiber optic links, while supporting software reconfiguration and advanced telemetry features to keep a pulse on the health of the network. Our pursuit to continually challenge conventional thinking and to develop truly differentiated products is in close alignment with the groundbreaking research prioritized by the DOE Office of Science and ESnet's vision for the underlying optical network required to support major scientific discovery. We're very proud of the partnership we've had with ESnet over the years, which has evolved as the network has evolved. A decade ago, back in 2012, we were deploying 100 gigabit Ethernet services using our TTM platform. And today with ESnet6, we're deploying our Flex ILS C+ L-band optical line system and our GX compact modular optical transponders. Scientists will benefit from one of the most advanced optical networks in the world, built on 15,000 kilometers of dedicated fiber and 46 terabits per second of capacity. And what's truly amazing, what Inder just demonstrated live, is that this can be dynamically provisioned around the network. This optical superhighway will provide a more efficient platform for scientific discovery and support critical research that relies on the generation, transmission, and processing of large data sets, such as genomics, energy, high-performance computing, and quantum information science. So to conclude, I'd like to congratulate ESnet, the DOE, and the Lawrence Berkeley Lab on behalf of Infinera. And we look forward to the groundbreaking research that ESnet6 will produce. Thank you.
Thank you. Next, I would like to invite Mike Loomis, who's the general manager of Nokia Federal. He leads Nokia's engagements with and product investments, and he has a deep understanding of technology. And he was working with us in ESnet5 as well, so please.
So thank you, Inder, and thank you to the ESnet team. It's really an honor to be here. And it was a pleasure to be involved, I think, almost a decade now with ESnet. Very, very proud of that. ESnet's a different kind of networking experience for us. It's a different kind of network, and it's not something you get to do every day. It's a meaningful venture with really meaningful applications. And as I was packing to come to California, my wife says to me, "So, honey, what are you going to do this week in California?" And I said, "Well, funny you should ask. We're going to go to the commencement of a network that transports experimental data from the Large Hadron Collider back to physicists. Oh, and by the way, this same network also takes X-ray crystallography and transports that back to NERSC to help decode the SARS-CoV-2 virus." And that's not something you get to say you do every day in this industry. And it's certainly more gratifying than working on solving the problem of making sure a streaming service doesn't pixelate or the social media screen scrolls down very quickly. Our role in this network, we're the router, so I get to sit between my colleagues from Infinera and Ciena. We take the packets off the optical network. We look at those packets. We decide what the best path for them to get to their destination, and then we ship them down their way. Our usual role is in large telecommunication service provider networks, and they select us for reliability and performance, but really it turns out that usually they buy our routers as an insurance policy because they never really get maxed out except during systems tests and certification tests. And that's not true with ESnet, and that's one of the reasons why we really love being part of this, is we get petabytes of data thrown at us at line rate, and the router has to perform, and that's not easy for a lot of reasons. And I started thinking about this, all of what had to happen to get this state of art of equipment, not just from Nokia, but from all our partners here to deliver this capability. I'm like, wow, all right, that's pretty interesting what went into this. So if we look at the 7750 router, it's a 56 terabit per second router. It supports 400 gig interfaces, which are just astounding to me. Thinking back at my early career, worrying about getting a 10 megabit Ethernet interface going. Those 400 gig interfaces can support 800 gig today as soon as the commercial optics are ready. And we've shown it to transport terabit flows over our own proprietary optic. And those are strange looking cards. And a lot goes into that. You can't do that. This is, to accomplish that, you're processing billions of packets per second. Each one of those packets you have to take, look it up, take stats on it, decide where it needs to go. Sometimes you decide this packet doesn't belong here and you need to drop it. And that wouldn't be possible without an ASIC development to support this. And that takes a very long time. A lot of people work into building those ASICs, packaging up into the system. And for these particular ASICs to handle that kind of capacity, we had to solve a few hard problems, a couple of interesting ones. We solved them down the street in Sunnyvale, California. We do the design and R&D for the system and the ASICs. But we had to get 56 gig SerDes working. And that's how to get bits off the wire and the traces on the circuit boards on and off the ASIC, which turns out is one of the hardest problems at operating at this kind of capacity. That was a problem we solved. Another problem is to operate at that speed for billions of packets per second, we needed to have memories that were much faster than commercially available. And we had to design our own memories, very high speed memories, to take that information on and off the chips to do these very fast lookups. I thought about all that and I think, well, isn't it awesome that all that research and development went in to provide a network to provide this kind of research? So thank you for letting us be part of that.
Thank you. Now I would like to invite Gordon Brebner, Senior Fellow, Adaptive and Embedded Computing Group. Thank you, Gordon. Yeah.
So hello, everyone. It's great to be here, and congratulations, Inder, on this technical triumph being unveiled today. And being from AMD, I'm surrounded by the giants of optical networking here. So you might think, what's AMD got to do with this? And it's actually an excellent example of kind of industry government partnership in the research. 4 years ago, we started a little research collaboration here, facilitated by Inder. I'll mention Yatish Kumar here in the audience of ESnet, and Chris Neely of AMD here have been instrumental. And basically, we were looking at what would happen if we added adaptive computing technology or FPGA technology, which is our bag, into the network. And that led to what's Inder revealed as the packet microscope, enabling you to look at every packet and just analyze what's going on, diagnose the network, dynamically adjust the loads. And this came out of what started as a little research collaboration. And now we have the technology in every node of ESnet6, which is tremendous, from my point of view. But going beyond that, Ian mentioned the smart instruments, etc. Now we've moved on the research collaboration, we've got into the production network, into what happens at the endpoint. And what we're looking at is, ESnet can deal with fire hoses of data for sure. That's why we're here today. But there's even more data coming off the instruments. So working, for example, with the advanced light source here at Lawrence Berkeley, we're looking at using the adaptive technology to filter and distill data before it even gets to ESnet. And then at the other end, at the supercomputing, looking at doing load balancing. This is in the Jefferson Lab, for example, load balancing the data that's coming off and heading for supercomputers. So really, it's the beginning of a mission for us. It's in the network. We have the flexible technology, for the 10-year or whatever lifetime of the network, we can change things and adapt the hardware, which is my business. So it's a real delight to be here. AMD was very proud a few months ago to be powering Frontier, the first exascale supercomputer in the world, and now to be here today also with AMD helping to power ESnet6 really puts the pieces together. So congratulations, Inder, and everyone in the room, and especially Yatish, my best friend and collaborator here at ESnet.
I would like to go to Lumen. Zain Ahmed is a Senior Vice President of Lumen Public Sector. He's joining us virtually live. So I don't know if the control room can get Zain on screen.
Good morning. I'm excited to join this impressive lineup of speakers this morning for the unveiling of the next generation ESnet6. Thank you, Inder, for the great presentation and tremendous leadership. I know this was really hard to work through during COVID challenge times, and the supply chain was not any easy task to work through. What is Lumen doing? Lumen has been a long-time provider for ESnet and providing the high-speed fiber backbone that lays the foundation for the ESnet, which is laid upon. So our co-location data center and fiber connection act the building blocks that enable ESnet to expand its 15,000-mile network faster with increased capacity over time as data demands continue to grow exponentially. As Inder has noted, ESnet has experienced an amazing 60% annual growth in network traffic over the last 30 years, and which now ESnet has ability to offer 400 gigs to 1 terabyte service. That's pretty amazing for an education network to be able to move so quickly. And he just displayed to us like how quickly they can actually provision these services. And ESnet has long served as the department's data circulatory system that connects tens of thousands of DOE-funded researchers, not only with each other, but also with the global research and education institutions like the CERN Super Collider in Geneva. As a company, we're committed to doing our part and happy to support DOE achieve its mission. And we'll continue to be part of this great mission and making sure that breakthroughs in innovation and scientific research continue to happen. Thank you for having me. I apologize for not being there in person, but happy to join virtually. Thank you, Inder.
Thank you, Zen.